Hello everyone, a very good evening to all. Once again, I welcome you all for this 8th introduction session on atomic and molecular physics course, which is being taught this semester in January 2025 by NPTEL with course code NOC 25PH04. Myself, Vivekananda Naik, I am a PhD research scholar in the Plasma Physics Laboratory, Department of Energy Science and Engineering, IIT Delhi. So today we will be solving a few problems that will be based on week 8 lectures of atomic and molecular physics course. Now talking about the concept that was covered in this week's lecture, it contains a few lectures related to the quantum mechanical treatment of hydrogen like atom, which was being continued from the last week also. So we will also solve a few problems related to that. Then lectures were about atoms in magnetic field and atoms in electric field. Basically, what happens to the atoms when they are present in the magnetic field. So the effect of splitting of spectral line occurs when the atom is placed in the magnetic field, and which is called as Zeeman effect. Similarly, due to the presence of external electric field, the splitting is called as Stark effect. So first we will discuss a few things, few concepts that was we will discuss briefly. It was covered in this week's lecture, and then we'll start solving the problems. So quantum mechanical treatment of hydrogen atom we have almost discussed in the last interaction session at the beginning. So like so there are some other information like fine structure. So from the fine structure there was less coupling and JJ coupling, and that was due to the spin of electron, that is electron spin. So initially only orbital angular momentum was known to us, that is the atom which revolves around the in an atom. When electron revolves around the nucleus, then there is orbital motion of the electron. So corresponding to that orbital motion there is orbital angular momentum, then orbital dipole moment and all that things. However, it was found that along with the electron revolving around the nucleus, it also revolves around its own axis, like earth revolves around its own axis, also it revolves around the sun. So due to the in discovery of electron spin, then it was found that there will there will be interaction between orbital angular momentum and spin angular momentum, due to which the atomic level they split into different some further labels. That's why there are fine structural spectrum, that is one component, that is suppose there are transition from 2p to 2s, but we found that there are more levels, like 2p will be split into 2p half and 2p 3 by 2 like that, and then 2s will be 2s half. So there will be at the place of one there will be two spectral lines. So that was hyperfine fine structure of spectral line. Now if you consider another type of structure which is called as hyperfine structure, and hyperfine structure basically like the fine structure is due to electron spin, hyperfine structure is due to nuclear spin, because nucleus also revolves around its own axis. So the energy change due to hyperfine structure, or due to the presence of nuclear spin, is I vector dot j vector, where I is nuclear spin and j is total angular momentum. Similarly, if we talk about the component, then uh, like in total angular momentum, J was L vector plus S vector. Similarly, F is I vector plus J vector. So, if you talk about the quantum mechanical treatment, so quantum mechanical we can write. So quantum mechanically we can write energy due to interaction between nuclear spin and total h plus square by 2 f into f plus 1 minus I into I plus 1 minus j into j plus 1, where f is called as hyperfine quantum number. So the selection rule will be delta f is equals to 0 plus minus 1, where 0 to 0 is not allowed. Then also there so due to the nuclear spin there was splitting of spectral line, that was called as hyperfine structure. Then there is another type of shift which is called as Lamb shift. So Lamb shift is found basically when two states have same value of n and j. So if they have same value of n and j, then energy should be same. Energy should be same, but it was found by Rutherford and Lamb that there is a energy difference between the two labels. For example, if you talk about the labels 2s half and 2p half, suppose there are labels 2s half and 2p half. Here j equals to half for both the cases, and here 2, that is n equal to 2 for both, but there is some gap between energy which is called as Lamb shift. Again, if we go towards the effect of magnetic field on atoms, so effect of magnetic field, we can call it as G-man effect. So in G-man effect, what happens? There are basically two types of G-man effect. One is normal G-man effect, another is anomalous G-man effect. So normal G-man effect, what happens? It occurs only between the singlet states. So where spin is equals to 0, but in anomalous effect spin is not equal to 0. So in normal G-man effect, what happens? One spectral line splits into three spectral lines which are equally placed, equally spaced. However, in case of anomalous Zeeman effect, one spectral line splits into more than three spectral lines. One splits into more than three spectral lines which are unequally spaced. Now, let's discuss how the splitting occurs. So we know when an atom is in an atom, when electron is revolving around the nucleus due to the orbital motion of electron. Let's start discuss about normal Zeeman effect. So what happens when an atom is revolving around when an electron is revolving around the nucleus, then when there is no spin we are considering, in case of singlet states, that is spin angular momentum becomes 0. So there is only orbital angular momentum. And if you talk about the corresponding magnetic moment due to the orbital angular momentum, then it will be mu L vector, that we have already discussed in vector atom model. It is minus GL mu B by h cross into L vector. Now we know GL is 1 for orbital component, so mu L will be minus mu B by h cross L vector. So what happens when this is present in an external magnetic field? Then there will be interaction energy. So interaction energy will be delta E, which is equals to minus mu vector dot B vector, that is minus mu B by h cross L vector dot B vector. Now If you talk about L vector dot B vector, then it will be LB cos theta. So LB cos theta is L cos theta is nothing but the Z component of L vector. So we can write as delta E equals to mu B by H cross B Lz. So again we know Lz is equals to ML H cross. So delta E will be mu B B ml. So depending upon the value of ml, the label will be splitted. So in case of initial label, it was ei, so it will be splitted into ei plus delta ei, which will be e0i plus mli mu b into b, like that. So when you talk about the transition, suppose the transition occurs from EF to EI, where it produces radiation of wavelength nu, frequency nu. So if you calculate, nu will be nu 0 plus delta ml EH by 4 pi m B by H. So this is the case of normal Zeeman effect. So what happens? You can write it in otherwise. Nu is nu 0 plus delta ml delta nu. So the shift in frequency is EB by 4 pi m. So it gets cancelled out. So EB by 4 pi m. So this is the case of normal Zeeman effect. So in normal Zeeman effect, since there is only L, so selection rule will be ml is equals to 0 plus minus 1. So this is one label, it is 2. So there will be 3 labels, it will be splitted into. But let me add another slide. However, in anomalous Zeeman effect, what happens in anomalous Zeeman effect? So spin is not equal to 0. So L vector plus S vector, they gave rise to total angular momentum J vector. So mu J vector will be minus Gj mu B by H cross J vector, where we know the lambda G factor Gj is given as by the formula 1 plus J square plus A square minus L square divided by 2J square, which is equals to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2 J into J plus 1. So it is called as lambda G factor. So accordingly, it mu Z will be minus Gj Mj mu B. So delta E will be Gj mu B B Mj. So corresponding to the value of J, so here delta J is equals to 0 plus minus 1, where 0 to 0 is not allowed. So accordingly, they will be splitted into different lines, and we will get nu is equals to nu 0 plus Gj final Mj final minus Gj initial Mj initial delta nu. So this will be the shift in the energy level or shift in the spectra. This is, similarly there is another effect which is called as Paschen-Beck effect. So in case of Paschen-Beck effect, what happens? In case of strong magnetic field, due to the presence of strong magnetic field, the coupling between L vector and S vector that gets weakened, due to which J has no significance, then it will be splitted according to the combination of the value of ML and MS, that is 0 plus 1 minus 1 and minus half plus half. So there will be suppose there are 3 values of ML and 2 values of MS, so there will be 3 into 2 6 combinations, so there will be splitting into 6 levels. So there will be other spectral lines that was present in anomalous Zeeman effect. Then another there is that is called as Stark effect. So there is one is linear, another is quadratic. So we will be solving a few problems based on these concepts. So now let's start. The first problem says an atom in its singlet state is subjected to a magnetic field induction B. The G-man splitting of its 600 nanometer spectral line is 0.04 nanometer. Then find the value of B. Options are option A 1.536 Tesla, option B 2.356 Tesla, option C 1.875 Tesla, and option D 0.85 Tesla. So here the question says the atom in its singlet state. So as you can see, it is in a singlet state and it is subjected to a magnetic field of magnetic field intensity B. Then there is G-man splitting of 600 nanometer spectral line, which is splitted into 0.04 nanometer. Then find the value of B. So I'll give you a few minutes to think about this question and then we will discuss how we will solve this question. So if you see in the discussion we made, we found that delta nu was EB by 4 pi m. So delta nu was EB by 4 pi m, and we know nu is equals to C by lambda. So delta nu will be minus C by lambda square delta lambda. That implies EB by 4 pi m is equals to minus C by lambda square delta lambda. So delta lambda, if we take only the magnitude, so it will be EB lambda square divided by 4 pi mc. So this will be the formula we need. This is the formula that we need for calculating the value of B. So here you can see, here it is given the atom is in its singlet state. So in its singlet state means uh, S is equals to 0, because then 2s plus 1 will be 1 only. So this is the case of normal Zeeman effect. And also in normal Zeeman effect, we had calculated the split in spectral line will be EB by 4 pi m at the delta nu. So this is the formula, delta lambda is equals to EB lambda square by 4 pi mc. So what will be the value of B? B will be 4 pi mc delta lambda by E lambda square. So if you put the values, 4 into 3.142 into mass of electron 9.1 into 10 to the power minus 31 kg into speed of light in vacuum 3 into 10 to the power 8 into 0.04 into 10 to the power minus 9 divided by 1.6 into 10 to the power minus 19 into lambda square. So lambda was 600 nanometer. So it will be 600 into 10 to the power minus 9 square. So this 0.04 is 0.04 nanometer. That is, in the question it was given lambda was 600 nanometer and delta lambda was 0.04 nanometer. So if you calculate, it will give you 2.356 Tesla, which will be the correct answer. If you see the options, correct option will be option B, that is 2.356 Tesla. So I hope this is clear to everyone. Now we will move to question number 2. Question number 2 says, which of the following term is not possible? Options are option A 2s half, option B 2p half, option C 2d 3 by 2, and option D 2d half. So this question is based on the concept of the spectroscopic terms in arising from LS coupling. So if you remember the concept of LS coupling, it will be easier for you to solve this question, because in LS coupling the spectroscopic notation is 2s plus 1 L J. So this is the notation. So we, for each option we need to identify what is the value of S, what is the value of L, and what is the value of J. Then depending upon the value of S and J, there will be corresponding J values. So out of which for some for combinations of S and L, there are j values that are not feasible, but that will be so that will be the correct answer. So I'll give you a few minutes to think about this question and solve it, and then I will discuss what will be the correct option. So now let's discuss the options one by one. So the first one is 2s half. So for 2s half, 2s plus 1 is 2. That implies s is half. And then for s, L is 0. So for S is equals to half and L equal to 0, possible J values is, so possible J values are half plus 0, half minus 0. So both are same, that is only half. So J is half. So here also we are finding J is half. So this one is written correctly. Then we will think about 2p half. So for 2p half, similarly 2s plus 1 is 2, which gives s is half. For p, L is 1. So for s half and L 1, J values will be 1 plus half, 1 minus half. So 1 plus half is 3 by 2, 1 minus half is half. So there is no in between, so there is no other values with 1 decrement in between. So possible values are 3 by 2 and a half. So it will be 2p 3 by 2 and 2p half. So since 2p half is here, so this is also written correctly. Now there is the option C, 2d 3 by 2. So this is 2d 3 by 2. 2d 3 by 2, again 2s plus 1 is equals to 2, which gives s equals to half. Then for d, L is 2, SPD. So s equals to half, L equals to 2. So J values will be 2 plus half and 2 minus half. So 2 plus half is 5 by 2 and 2 minus half is 3 by 2. And there is no values that we can get by decreasing 1 from the values of 2 plus half. So the possible terms are 2d 3 by 2 and 2d 5 by 2. So 2d 3 by 2 is given in the option. So 2d 3 by 2 is written correctly. Now you see the fourth option was 2d half, but here we found J values are only 5 by 2 and 3 by 2, corresponding to the value of L and S. So J can't be half for S equals to half and L equals to 2. That's why this is not written correctly. And if you see the options, option D will be the correct option because this term is not possible. So 2D 5 by 2 is possible and 2D 3 by 2 is possible. 2P half, 2S half are possible, but 2D half is not possible. Similarly, let's check another term. So let's check another term. For example, I will write 3D 5 by 2, whether it is possible or not. So 2s plus 1 is 3, that implies s is 1. So again for D, L is 2. So corresponding J value will be 2 plus 1, 2 minus 1. So 2 plus 1 is 3, 2 minus 1 is 1. So there will be 2 in between. So J value is 1, 2 and 3. So the spectroscopic term will be 3D1, 3D2 and 3D3. So J 5 by 2 is not possible. So this spectroscopic notation is not feasible according to the concept that we have been discussing. I hope this is clear to everyone. Now we will move to the next one, that is question number 3. Question number 3 says the wave function for a 1s electron in the hydrogen atom is given by psi equals to 1 by pi aq pi a0 to the power 3 by 2 exponential minus r by a0, where a0 is the smallest Bohr radius and r is the distance of the electron from the nucleus. Now find the average or expectation value of 1 by r for this wave function, given that the elementary volume in spherical polar coordinate is dv is equals to r square dr sin theta d theta d phi, where the options are option A 1 by A0, option B 2 by root A0, option C 3 by root A0, and option D 1 by root A0. So this is a very good question. This question basically, if you remember, in the last interaction session, we had solved a problem where we had calculated the expectation value of R only. But here the question says what will be the expectation value of 1 by R, and the state is the ground state, that is 1s electron. So the ground state wave function is given to us. Ground state n equal to 1, L equal to 0, and S equal to m is equal to 0. So it is 1 by pi a0 q to the power half exponential minus r by a0, where a0 is the Bohr radius. So what will be the expectation value of 1 by r, that we need to find out. So I'll give you a few minutes to think about this question and solve it, and then we will discuss. So let's start. So we know in quantum mechanics, the quantities that we calculate are the expectation or average values of those quantities. So according to the formula, the expectation value of 1 by r will be integration 1 by r psi star psi mod square dv, and dv is given to us in spherical polar coordinates r square sin theta d theta d phi dr. So if we solve it, so 1 by r expectation value will be equals to, so you see 1 by pi a q, so let's write 1 by pi a0 cube to the power half exponential minus r by a0 into 1 by r into 1 by pi a0 cube to the power half exponential minus r by a0 r square sin theta dr d theta d phi. So this 1 by pi a cube half into 1 by pi square, it will be coming outside, so it will be r terms. First let's first take only r terms, so it will be 1 by r into r square, so it will be r exponential minus 2r by a0 dr integration sin theta d theta into d phi. So what will be the limit of integration? It will be 0 to infinity, theta is 0 to pi, and phi is 0 to 2 pi for spherical polar coordinates. These things we have discussed in the previous interaction session. So if anybody has any problem, so they can visit that video which has been uploaded in the YouTube. So it will be finding that value. So we will solve the integration. Suppose let's first solve integration of r e to the power minus 2r by a0 dr. So we will take the rule of integration by parts. So in that case, it will be r integration of exponential minus 2r by a0 dr minus dr by, so this will be d by dr of r into integration exponential minus 2r by a0 dr. It will be r minus a0 by 2 exponential minus 2r by a0, limit will be 0 to r, then minus, so 1 minus a0 by 2 will come for one integration, then another integration there will come another minus a0 by 2 term, so it will be minus a0 by 2 square into exponential minus 2r by a0, limit will be again 0 to infinity. Now if you talk about the first term, in the first term when we put r equal to 0, it is 0, and when we put r equal to infinity, Due to the exponential term, it becomes 0. So the first term becomes 0 for both the cases. So now the second term, if you see, second term will be minus a square by 4, sorry, a0 square by 4, that will taken outside. Then e to the power minus 2r by a0, 0 to infinite. Then minus a0 square by 4 into exponential minus infinity minus exponential 0. So it will be minus a0 square by 4 into exponential minus infinity is 0 minus 1. So it will be a0 square by 4. So the total integration will be, we know the integration of uh, sine theta d theta d phi, where theta is 0 to pi, phi is 0 to 2 pi, will be 4 pi. So the expectation value of 1 by r will be how much? It will be 1 by pi a0 cube, that was already taken outside this term. Then the r term gave us a0 square by 4 into 4 pi, that is this integral. So this is equation 3, this is 2, and this is equation 1. So if you put all the values in the values of equation 2 and equation 3 in equation 1, you will get, so 4 gets cancelled out, pi gets cancelled out, a square aq, so there will be only 1 by a0. So the correct answer is 1 by a0. I hope this is clear to everyone. Now we will move to the next one, where the question says the normalized radial wave function of the hydrogen atom for n equal to 1 is given as r, which is a function of small r, is equals to 2 by a0 to the power 3 by 2 exponential minus r by a0. So in the last question, it was the whole wave function, that was, it has components of r as well as theta and phi, but here it is only radial wave function, which is normalized radial wave function. So it has only r terms or r part, that's why the root over pi term is not here. It is 2 by a0 to the power 3 by 2 exponential minus r by a0, where a0 is the smallest Bohr radius and r is the distance from the electron to the nucleus. Then find the ratio of probability. So this is ratio, not radio, this is ratio. Find the ratio of probabilities of this wave function for r equal to a and r equal to 3a0. So how we will calculate? So we will see that in the solution, where the options are option A 1 is to 3, option B 9 is to 1, option C 6 is to 1, or option D 3 to the power half is to 1. So we need to find out the probabilities of the wave function, the ratios of probabilities of wave function, where r is a0 and r is 3a0. So we know the probability of finding the electron is given by using the radial wave function. So probability here is r square and r mod square, that is the mod of the radial wave function. The radial wave function is given, which is 2 by a0 to the power 3 by 2 exponential minus r by a0, where a0 is the Bohr's radius. Now, if we talk about the ratios when r equal to a0 and r equal to 3a0, then how we will calculate? So, probability at r equal to a0 and probability at r equals to 3a0 will be r1 square, r1 mod square, r2 square, r2 mod square. So, r1 square is a0 square divided by 3a0 square into r1 mod square. R1 mod square means it is, so at the place of r1 mod square at r equal to a0 and r equal to 3a0. So it will be exponential minus 2 plus minus uh, 2 by, it was exponential minus r by a0, so it will be minus 2r by a0 at r equal to a0 divided by exponential 2r by a0 at r equal to 3a0. It will be a0 square by 9a0 square into exponential minus 2a0 by a0 divided by exponential minus 2 into 3a0 by a0. So it will be 1 by 9 into exponential minus 2 divided by exponential minus 6. It will be 1 by 9 into e to the power minus 2 plus 6. So 1 by 9 into e to the power 4. So 1 by 9 into e to the power 4 means it is 2.71 to the power 4. It is 53 point, so it is 53.9. So to be so if you take it to the nearest integer, so it will be 1 by 9 into 54. It is 54 by 9, that is 6 is to 1. So the correct option will be option C, that is 6 is to 1. So if you see in the Bohr's model, we found that for an electron which revolves around the nucleus at different energy levels, in that we had obtained that R is equals to n square h square epsilon 0 by pi m jd square. So R was direct proportional to n square. So here if you see a0 and 3a0, So it should be 1, so it will be 9. So generally it should be 9:1, but it is not. So but if you remember in the last interaction session, we had solved a problem. We have to find out the maximum probability or the most probable value of R for n equal to 1 and n equal to 3. So in that case, the most probable value of R for n equal to 3 we will get as 9A0, which is inconsistent with the Bohr's theory. I hope this is clear to everyone. Now we will move to question number 5. Question number 5 says, for orbital quantum number L equals to 2, how many orientations of orbital angular momentum L vector is possible in presence of external magnetic field? The options are option A 2, option B 3, option C 4, and option D 5. So question says, for orbital quantum number L equals to 2, how many orientations of orbital angular momentum L vector is possible in presence of external magnetic field? So if you remember, this is the case of space quantization. So we know for L equals to 2, possible values of ML will be plus minus 2, plus minus 1 and 0, that is minus 2, minus 1, 0, 1, 2. And we know when we talk about the possible orientation of L vector in presence of external magnetic field. So in case of external magnetic field, we take the component of L vector along the magnetic field, which is Lz, that is ML h cross. So for ML equals to 2, 1, 0, minus 1, minus 2, we will be having. So what do we mean orientation? If you remember, the orientation was cos theta was Lz by L vector mod. So theta will be cos inverse ml by L into L plus 1 root over. So since there are 5 possible values of ml, 5 possible ml values, that implies 5 possible orientations. So the correct option is option D, that is there will be 5 possible orientations in presence of external magnetic field. Now let's move to question number 6. So question number 6 says, an electron is revolving on the plane of paper, that is in xy plane, in clockwise direction as shown in figure. The direction of angular momentum vector L vector is along, options are along plus z direction, option B along plus y axis, along C along minus z axis, or along minus x axis. These are the 4 options. So here you see it revolves. So this is xy plane, this is z, this is x, this is y. So it is moving like this from y to x. It is moving along this direction, so which is clockwise direction. So we need to find out the direction of L vector, that is angular momentum vector L. So I'll give you a few minutes to think about this question and then we will discuss. So if we discuss about the direction, so the direction of L vector is generally governed by the right hand thumb rule, where the what right hand thumb rule says. So the right hand thumb rule says, suppose this is the thumb, and then these are the fingers. So if this fingers, so this is the direction of L vector, and the orientation of the fingers give the direction of the orbital motion. So if we see in the question, it was along clockwise direction. So if you see, the orientation is along here, the orientation is along anti-clockwise direction, that is in the this direction. But in our question, it is in clockwise direction, that is along this direction. So it should be, so L vector should be in minus z direction, that is this is y, this is x, and this is z. However, if you see, electron has negative charge, so electron has negative charge, that's why the direction will be opposite that of the this right hand thumb rule, so it will be along plus z axis. So the correct option will be, so plus z axis. This is for positive charge, but for since electron has negative charge, its direction will be opposite to that, that will be plus z axis. So the correct option will be option A. Is this clear?
Yes, sir.
Okay, so we will move to the next one. If you remember, in the during the uh, week where there was lectures related to the vector atom model, there we had calculated L vector. So the L vector was, so L vector expression was, it was some L vector was minus E by 2m h cross like that. So this due to this negative sign, its direction becomes opposite. So according to the right hand thumb rule, it will follow the opposite direction. So if this is the direction of motion, then the value of the direction of L vector will be opposite to the actual direction, that is plus z axis. Now we will move to question number 7. Question number 7 says, a spectral line of wavelength 4250 angstrom is emitted in a transition of an atom which exhibits normal G-man splitting when placed in a uniform magnetic field of 5 Tesla. Calculate the separation delta lambda between the splitted lines, where we need to calculate only approximate values, where options are option A 0.426 Armstrong, option B 0.325 Armstrong, option C 0.085 Armstrong, and option D 0.244 Armstrong. So can you tell me how we will solve it? Yes, do you have any idea how we can solve this question?
No, sir.
So if you see the lectures, are you following the lectures of this week's? So this week's lecture was mainly about the effect of magnetic external magnetic field on spectral lines, that is G-man effect. So in G-man effect, there are basically two types of G-man effect. One is normal G-man effect, another is anomalous G-man effect. So here the in question it says it exhibits normal G-man effect. So in normal G-man effect, what happens? The transition uh, is only between singlet states. So I request you to mute yourself because there are some unwanted background noises that is coming. So for singlet state, singlet means its multiplicity is 1. So if 2s plus 1 is 1, then s will be 0. So there is no spin. So we don't need to consider any spin. So here we need to consider only orbital quantum number L. Orbital quantum number L has the significance. So in that case, each spectral line in absence of magnetic field gets split into 3 equally spaced spectral lines. So one transition will get split into 3 equal transitions. Why it will split into 3 equal transitions? Because in that case there is interaction between the orbital angular momentum and due to the orbital motion of electron, there is orbital magnetic moment, and when the atom is placed in an external magnetic field, there is interaction between magnetic field and orbital angular momentum, orbital magnetic moment, sorry. So due to this interaction there is splitting in the energy levels, and due to the splitting, since here only L has significance, the selection rule says delta ml will be 0 or plus minus 1. So one component corresponds to 0 and other two components corresponds to plus 1 and minus 1. So there are three components. So this is 1, this is 2, this is 3, this is 0, this is delta m minus 1, this is delta m plus 1. So we will solve this problem according to the concepts of normal G-man effect. So in normal G-man effect, what happens? So like here there is splitting. So this is suppose in lambda scale, this is lambda, basically this is in wave number scale, or 1 by lambda 0. So it is lambda 0, then it is plus del lambda 0, and it is minus del lambda 0. So but if you consider in terms of frequency, so the original frequency gets changed into nu 0 plus delta nu, and delta nu value, if you see the discussion that I had also discussed it at the beginning of the session. So the delta nu comes out to be EB by 4 pi m. So this is the same frequency, if you remember, about Larmor fission, because in Larmor fission also there was orbital momentum or orbital motion was considered. So here also the shift in frequency is EB by 4 pi m. So by using this EB by 4 pi m, so this is delta nu, and we know nu is equals to C by lambda. So if you use that formula, then we can calculate delta nu is equal to C by. So we know nu is equals to C by lambda. That implies delta nu will be minus C by lambda square into delta lambda. That implies EB by 4 pi m equals to minus C by lambda square delta lambda. But here you see we need to calculate only the separation, that is it should be the magnitude of delta lambda. So the magnitude of delta lambda will be EB lambda square by 4 pi mc. Is this clear? So using this equation, we will calculate the value of delta lambda, because we know the value of lambda. Lambda is 4250 Armstrong. So lambda is 4250 Armstrong, and another unknown quantity B is also given. B is 5 Tesla. B is 5 Tesla. Then what should be delta lambda? So can you calculate and tell me what will be the value of delta lambda? Just put the values.
Sir, I am in traveling, so couldn't calculate today.
Okay. Okay, so if you see, if you put all those values, so pretty simple. If you put those values, it is E is 1.6 into 10 to the power minus 19, B is 5 Tesla, into delta into lambda EB lambda square. So lambda square is 4250 into 10 to the power minus 10 square divided by 4 into 3.142 into m is mass of electron, 9.1 into 10 to the power minus 31 into c is velocity of light, that is 3 into 10 to the power 8 meter per second. So if you calculate, you will get 4 2 so you will get 42588 42588 into 10 to the power minus 16 meter. So if you convert it to Armstrong, so it will be 0.425 into 10 to the power minus 10 meter, which is equal to 0.425 Armstrong. So this will be the correct answer. So the so if you see the correct of so in order it will be 4 to 6. The 4 to 5 8 we can write as 4 to 6. So the correct option will be 0.426 Armstrong. I hope this is clear to you.
Okay, sir. Sir, that formula lambda naught is equal to lambda naught plus del lambda. How would that formula come, sir? That is, go to the previous page here.
Okay,
The
okay.
lambda naught is equal to lambda naught plus del lambda.
Okay, so you see here, so what happens in normal Zeeman effect, we know this is mu L equals to minus GL mu B by H cross into L vector. So if you put the value of L, so if you place it in magnetic field, then there will be interaction energy. It will be minus mu vector dot B vector. So there will be L vector dot B vector, and if you calculate, there will be a delta E term which will be mu B BML. So then what will be the energy? The initial energy will be split. There will be an additional term which will be E0 plus ML, this ML, mu BB, and then if you see similarly this is EI. So uh, do, let me do that once again. So you are So what happens in presence of external magnetic field? I show you that there will be some change in energy which is due to the interaction between the orbital magnetic moment and the external magnetic field. So what happens in that case? So if you see it was so EI was equals to E0I plus MLI mu B and EF is equals to E0F plus MLF mu B. Now when the transition occurs from I to F, then it will be delta E will be EF minus EI. It will be E0F minus E0I plus MLF minus MLI mu B. So if we talk about frequency, then frequency will be divided by h. So this will be E0F minus E0I divided by h plus MLF minus MLI mu B divided by h. And we know mu is EH by 4 pi m, is not it? EH cross by 2m mu B EH cross by 2m, which is equals to EH by 4 pi m. So if you put that, suppose this is nu 0 plus delta ml. So this is delta ml. Then mu b by h will be eh by 4 pi m into b divided by h. So it will be nu is equals to nu 0 plus delta ml delta nu, where delta nu will be eb by 4 pi m. Is this clear? This is called
Yes,
as
sir.
Gman. So this is called as the Gman shift or normal Gman shift, where only delta ml value we need, because in case of normal Gman effect, the transition occurs between singlet states. So S is 0 here. Now let's move to question number 8. Question number 8 says, let L vector be the total angular momentum for hydrogen atom and a magnetic field B is applied on it in z direction. Then the component of L vector in z direction may be equal to magnitude of L, always less than the magnitude of L, always greater than the magnitude of L, or option D, all of the above may be possible depending upon the value of B. So can you think about this question, how or what will be the correct option?
Sir, is it D?
No, so how you are saying it will be D?
Sir, based on Hall effect, I thought of,
Sorry.
sir, here once
So
our
can
teacher
you tell?
taught the Hall effect.
No, can you tell
Hello?
me what is the expression for L vector and Lz vector, or what is the magnitude of L vector and what is the magnitude of Lz vector according to quantum mechanics?
You kindly say, sir.
So L vector is L into L plus 1 root over h cross, and Lz is ml h cross, isn't it?
Okay, sir.
So in that case, if you see, suppose L is 2. So let's take an example where L is 2. Then what is the value of L vector? So it is L into L plus 1 root over h cross. So it is 2 into 2 plus 1 is 3 h cross, that is root 6 h cross. So what is the value of root? So root 6 is greater than 2 h cross, is not it?
Yes, sir.
So it is always greater than, because root 6 is greater than 2. It will be 2 point something. So it is greater than 2 h cross. Now let's talk about the values of Lz. So if L is 2, what are the possible values of ML? Yes, it's pretty easy. For L equal to 2, what will be ML values?
Can't
Yes.
guess, sir.
ml is plus minus L 0, is not it? So there will be 2L plus 1 values. So ml is minus 2, minus 1, 0, 1, 2, is not it? There will be 5 values. So we found L vector mod is root 6 h cross, and since Lz vector mod is ml h cross, so it will be minus 2 h cross, minus h cross, 0 h cross, and 2 h cross. So these are Lz vector magnitude, and if you compare it versus L vector magnitude, which is greater than 2 h cross. So here we found the maximum value is 2 h cross. This is the maximum value and this is the minimum value. However, all these values are less than 2h. All these values are less than L vector magnitude, because the magnitude of L vector is 2h cross, is not it?
Yes, sir.
Also, if you see, there was a formula which calculated the angle between L vector and Lz vector, that was ml divided by L into L plus 1. So when ml is equals to L into L plus 1, in that case it will be 1 and then theta will be 0 or 180. But ml can't be equal to L into L plus 1 root over, that's why theta can't be 0 or 180 degree. So if theta is 0 or 180 degree, in that case only L will be equal to, or Lz will be equal to the value of L, because when theta is 0, in that case Lz vector mod is equals to L vector mod. When theta is 180 degree, then Lz vector mod is equal to L vector mod. But in both cases the direction here, they are in along the same direction, along same direction. This is along opposite direction, but both of these are not feasible, that is it can't be 0 degree or 180 degree. That's why Lz vector mod is always less than L vector mod. So the correct option will be option B. So this is option B, always less than the magnitude of L. So is this clear?
Okay, sir.
Okay, so now we'll move to question number 9. Question number 9 says, in how many sub-levels the term 4D 1 by 2 will split in presence of weak magnetic field? Options are option A 4, option B 3, option C 2, and option D 0. So here the state is 4D half. So for 4D half, 2s plus 1 is 4. Then what will the value of s? Yes, so when 2s plus 1 is equals to 4, what is s?
You please tell, sir.
Sorry?
You kindly tell, sir.
So it is pretty simple now. If 2s plus 1 is 4, then what will the value of s? You can calculate, na? It is quite easy. So this much you can tell, I can expect.
Since I'm in traveling, the network issues
So,
are there, sir.
so s is 3 by 2. So here s is not equal to 0. So this is the case of anomalous Zeeman effect. So here what happens in case of anomalous Zeeman effect, since S is not equal to 0, we will have the J component or the J vector, which is L vector plus S vector. So in that case, like in the previous case, delta E, so in a normal Zeeman effect, delta E was ml Eh by 4 pi m into B. So here in anomalous Zeeman effect, delta E will be Gj mj Eh by 4 pi m into B. So this will be the formula. So how many number of labels it will be splitted will depend upon the value of mj and the value of gj. So for j, here j is half, so mj will be having plus half minus half, so there will be two values, plus half and minus half. But again we need to find out the value of gj, where the formula for gj is 1 plus j into j plus 1 minus l into l plus 1 plus s into s plus 1 divided by 2 j into j plus 1. So in this case, j value is 1 by 2, s is 3 by 2, and l for d sub cell l is 2. So if you put these values, it will be 1 plus j is 1 by 2 into 1 by 2 plus 1 is 3 by 2. So 1 by 2 into 3 by 2 is 3 by 4 plus s into s plus 1. S is 3 by 4. So s is 3 by 2. So 3 by 2 into 5 by 2, which is 15 by 4, minus L is 2. So 2 into 3, which is 6, divided by 2 into 3 by 4. So if you calculate it, you will get 1 plus. So this is if you take 4 as LCM, it will be 3 plus 15 plus, sorry, minus 3 plus 15 minus 24 divided by 6 by 4. So 4 gets cancelled out. It will be 1 plus 15 plus 3 is 18 minus 24, which is minus 6 by 6. So Gj will be 1 minus 6 by 6, 1 minus 1, 0. So since Gj is 0, delta E will be 0. So delta E 0 means the label does not split, or the label does not shift in presence of magnetic field, in presence of weak magnetic field, because in this question it is given as weak magnetic field. So why weak? So let's first conclude this question, then we'll discuss why it is given as weak magnetic field. So here it will not split, that means the correct option will be option D, that is 0. Now if you think about the splitting, why it is mentioned here specifically that it is in weak magnetic field, because in weak magnetic field what happens, the coupling between L vector and S vector, that doesn't break. That's why here it is mentioned as weak magnetic field. So weak magnetic field is the case of anomalous Zeeman effect. However, if you talk about the strong magnetic field case, so strong magnetic field, what happens, the coupling between L vector and S vector, they get broken or they get disturbed or uncoupled, and according to the concept, the splitting will be depending upon the combination of ml and ms, because in that case both L and S have significance as they are independently revolving or orbiting around the total angular momentum around the external magnetic field. That's why in case of strong magnetic field, we will apply the concept of Paschen-Beck effect. I hope this is clear to you.
Yes, sir.
Okay, so now we will move to question number 10. Question number 10 says, in LS coupling scheme, the terms arising from two non-equivalent p electrons are. So, non-equivalent means both does not correspond to the same cell or that have same values of L. Sorry, non-equivalent means both does not correspond to same n value. So n is different for both the cases. So according to Pauli's exclusion principle, so what does it say? So what does Pauli's exclusion principle state? So Pauli's exclusion principle states that no two electrons in an atom can have all four quantum numbers equal. So for an electron, quantum numbers are n, l, ml, and ms. So in that case, in non-equivalent case, n1 is not equal to n2. So L1 can be equal to n2. So in that case, if you see for p electron, p means one electron is p, another is also from p. So p means L1 is 1 and for electron S1 is half. Similarly, L2 is 1, S2 is half. So when S1 is half and S2 is half, then S will be S1 plus S2 mod up to S1 minus S2 mod. It will be half plus half and half minus half, that is 0, 1. And when L1 is half, L2 is half, sorry, when L1 is 1 and L2 is 1, then L will be L1 minus L2 mod up to L1 plus L2 mod with 1 increment. So L1 minus L2 is 0, L1 plus L2 is 2, so it will be 0, 1, 2. So for S equals to 0, L equal to 0, J is 0, so the term will be 1s0. For S equals to 1, L equal to 0, J will be 1, so it will be 3s1. Again, for S equal to 0, L equal to 2, J will be 2, so this term will be S0 means it is 1, L2 means it is D, so it is 1d2. For S equals to 0, sorry, for S equals to 1, L equals to 2, J will be 1, 2, 3, so it will be 3D, 1, 2, 3. For again S equal to 0, L equal to 3, J will be 3, so it will be 1F3, SPDF, because for L equal to 3, F is 3, it is F. And for S equals to 0, sorry, S equals to 1, L equals to 3, J will be 3 plus 1, 3 minus 1, 3 plus 1 is 4, 3 minus 1 is 2, so it will be 2, 3, 4. So it will be 3F, 2, 3, 4. So what are the terms we got? We got 1S, 1P, 1D. So 1s, so this is 1, so L equals to, so sorry, I made a mistake here. So it will be L equal to 0, it will be 1. So not L3, it will be 1, because 0, 1, 2. So 1 means J is 1. So it is 1P, 1P1, and it is again 3P. This will be 1, 1 means it will be 0, 1, and 2. So it will be 3P, 0, 1, 2. So 1S, 1P, 1D, 3S, 3P, 3D. So these are the possible terms when two p electrons which are non-equivalent undergo LS coupling. Is this clear?
Yes, sir.
It is 1s, 1p, 1d, 3s, 3p, 3d. So for 3s, it is 0. So for 3s, it is 3s1, then it is 3d1 2 1 2 3, and 3p0 1 2. So 3s1, 3p0 1 2 1 2 3. So the correct option is option B. So I hope this is clear to you. Now with this
Yes,
we
sir.
come to the end of today's interaction session. So thank
Sir,
you for
here,
joining. Yes.
sir, in the final step, you have mentioned as 3S1, 3P12 like that, 012
Yes.
like that.
Yes.
Suppose, sir, how it is possible? Yes will be 2, always yes will be 2, no, sir. Unless it has been, only if it has been filled, only the P level will be occupied like that, I have heard.
Sorry, I could not get your question.
Sir, according to Paulus exclusive principle,
Hmm.
in our small, that is in our 11th plus 2 and all, we came to know that S level will be having 2 electrons in opposite spin.
Yes.
If we are having P in P shell, you will be having 6.
No, no.
So
This is
when
three
P
means
shell comes,
there are three labels having
mm,
same energy. So this is
mm,
the multiplicity. This is a triplet set. So when the electron is present, suppose this is a cell where the electron is present. So it can be one case, and in another case it can be like this. So this can be one case, this can be another case. So see, in both the cases here, for this case ml is same, here ml is different, but since our question says it is two non-equivalent p electron, non-equivalent means n1 is not equal to n2. So in that case we can consider this case also, we can consider this case also. So for all the cases, for electrons spin is half. So for two electrons s1 is half, s2 is half. Then for another electron, this corresponds to L1, this also corresponds to L1. So L1 is 1 and L2 is 1. So corresponding to those L and S values, we got the values of J, and then from J, S, L and J values, we got the spectroscopic notations.
okay,
Is this
sir.
clear?
Okay, sir.
Okay,
Okay,
so
sir.
with this, I conclude today's interaction session. So in the next session, we will
Last
solve a few problems.
last 2 weeks, the portions are very standard, sir. I haven't come across this kind of informations.
Okay, so
So
actually, if you follow the lectures, then it will be, so
in
it
lecture
will,
also, sir, everything is new for me. So I
okay,
must go
so
through again, sir.
exactly, you should revise it once again. If you have any doubt, you can ask me, or you can contact me over my email address. I had also mentioned in the initial days, so you can do that also.
It has been standard and it has been very heavy to my knowledge, sir.